if we really want to achieve something numerically zero, we also need to have a process which can be quantifiable. To me, one of the first step towards reaching the net zero is trying to understand how much do we really own in terms of buildings, or how many buildings have we built so far. Hi, I'm Rajan Rawal. I'm a professor at CEPT University and also senior advisor at the research center at CEPT University called Center for Advanced Research in Building Science. And you're listening to a podcast on understanding the future.
Hello everyone, I'm Punit Gandhi, Senior Associate with the Climate Center for Cities at the National Institute of Urban Affairs, and welcome to the Season 3 of Understanding the Future podcast. I have been working and studying in the field of sustainability and climate change for more than 8 years, and I have realized that I have a lot of questions on how we can build cities in India that are more climate focused. With Understanding the Future podcast, I interact with experts, entrepreneurs, and government officials to understand what it takes to bring all the different solutions to the ground, as well as how can systemic changes be developed on ground. We will further anchor all the topics being discussed with different skill sets required. This will help us understand the future of cities and future of work in Indian context. If you are tuning in for the first time, do check out our previous episodes. Also, don't forget to check out the Climate Practitioners India Network, a members-led solutions-oriented platform for climate practitioners across India, and join it through the show note. Hope you enjoy the podcast. Hello, and welcome to the Season 3 of Understanding the Future. I'm your host Punit Gandhi, Senior Associate with the Climate Center for Cities, and today we have with us Dr. Rajan Rawal. He is a Senior Advisor for Center for Advanced Research in Building Science and Energy and CRDF Professor for Building Energy Performance at the CEPT University. Today, he will help us understand the topic of built environment. Welcome to the show, Dr. Rawal.
Thanks, Punit. Thank you.
So I think let's start with the most basic question where we can start on built environment. What do we exactly mean by built environment? What are we looking at?
So, Punit, I think city itself is a built environment. If we really look at it that way, it would be impossible to separate out what is a built environment within the city. To me, it itself is a built environment. So, however, just trying to split a few things for better understanding. Anything which is a building instruction is, we can call it a built space, and something which is not built is sort of open space. Now, open space does not mean that anything which is not built is an open space. Open space also have a definition. You can't call alleys and small narrow lanes as a open space. Also, a lot of infrastructure spaces such as waste treatment plants or transport node depots and other things also are part of the cities. So to me, built, unbuilt together is an environment. Because the moment we build, we also create, or we also have an impact on unbuilt.
Yeah.
So my understanding about built environment in the city itself is a built environment.
Okay, so I just have a clarification. So when you say open spaces can also be part of it, the landscape gardens now that we have in city will also be part of somewhere built environment because it's somewhere built in.
Yeah, I would like to believe that way, that not just about manicured landscape spaces, but also large Hindi word called Maidan, certain private plots which are also not being occupied by buildings also is an open space. But again, it's like whether it is an unbuilt or it is an open, different of definition in that. To me, unbuilt is something which is going to have a buildings in future, but open is something the community or city will be using that for very long period of time. Now, whether it is garden or urban forest or just a Maidan.
Yeah, that makes sense. And so when we talk about it, I think one of the things that does come up frequently, because most of the now narratives is also going towards developing net zero or zero carbon kind of built environment. And so how do we kind of map that? Because in terms of specifically buildings and all, it's a huge area. How do we make sure that how many properties do we have and how will that affect the whole development of such kind of net zero approach or something?
Yeah, so the net zero itself suggests us that we should quantify and we should have numbers. Now, that means whether it is a carbon numbers or emission numbers or operational energy numbers. And when we are trying to reach towards either operational zero carbon or life cycle assessment zero carbon, it is a different point of discussion. But if we really want to achieve something numerically zero, we also need to have a process which can be quantifiable. And to me, one of the first step towards reaching the net zero is trying to understand how much do we really own in terms of buildings, or how many buildings have we built so far in a city. Although numbers about cities are available, that 400 square kilometer of city area or urban area or urban agglomerate, out of that 7, 10, 15% is rooftop area, or rather footprint area. Sometimes some cities talk about 22%, 25% as well. Then 13, 14% is road network and so on and so forth. But what we do not really know is that total amount of floor space, because the third dimension comes into the picture. Although I may have 200 square kilometer of my city having the built spaces on or the footprint, but that 200 square kilometer may be occupying about, or maybe housing about 400 square kilometer of floor space. So footprint versus floor space is again something which we need to distinguish and understand. So when I say what is the building stock do we have, that means that how many buildings do we have, what are the characteristics, how are they going to be used, how old they are, how new they are. And as far as my area is concerned, primarily to embodied energy and operational energy, we also try to understand what are the thermal characteristics of these buildings.
So in that case, when we are looking at it, there's quite a lot of parameters that we are trying to look for. But is it available in cities easily? Because and how can we actually get this kind of data to be able to even start analyzing what is required?
So until you ask, you're not going to get it, right? So data generally doesn't get created or doesn't get gathered until somebody demands for it, until somebody feels that now I think we really need a data to understand how do we reach to net zero carbon or net zero energy. So data definitely is not available. If at all it is available, it might be in a semantic fashion. It may not be a spatial data. If at all it is available, the quality of data also needs to be looked at. Because, for example, if I give the property tax data, is one of the closest data set which we can look at. How many buildings do we have in a city? But whether do we have that property geo-tagged on a city, or do we really know how old that building is, or whether that particular building is using an air conditioner or high electricity consuming equipment or not. So when we are moving towards, and again repeating, moving towards zero or net zero, trying to move towards that, there are few iterations or few avatars of property tax data is required for us to look at. But to say it is not available, it is not correct. But also to say it is available, it is also not correct. probably we need to incarnate property tax data in number of ways to make it usable for what we want to do.
Okay. And so let's say that we have been able to create or been able to source all these data this much of efforts, and we now have somewhere close to the whole city's data on the lines of how where are the buildings, what is the space, all different kinds of characteristics in place as well. Now, on a city level, how can that data help us determine any kind of way forward?
So, number of ways. Like, say, if we let me give you a couple of examples. Let's say if we are going for certain kind of urban renewal projects where more FSI 1 in 1 square kilometer would be turned into FSI 4 because of the transport oriented development, or because that land area is been designated as a central business district, or whatever it is. For any kind of urban renewal project, obviously the development will take place. Development will have an impact on carbon emission. But if we know what is the base case or what is the current situation right now in terms of amount of building and their carbon footprint or their operational energy numbers, what we can do is that we can achieve our developmental goals by having a higher floor space or whatever, but at the same time we can embed certain kind of design decisions, embed certain kind of code compliance within that 1 square kilometer to make sure that our carbon intensity, operational carbon intensity, doesn't go up and remains at the same level as FSI 1. So let's say in 2022, my energy performance or whatever index is 1. Even in 2042, it should remain same despite I'm having a more floor space. So I think those are that is one where one can use this data. One can sort of build upon our future looking at some of these data. Second is not just about what city wants to do or what city government wants to do or state government wants to do. It's also industry needs to have a certain kind of signals when you start looking at some of these data. So, for example, again, if I go back to that 1 square kilometer of space in one city or built up space in one city, and if we are looking at any kind of policy intervention like energy conservation building code or Econeva Samhita, industry also needs to come forward and envisage that what would be the what do you call a market requirement for better insulation or better glass or better air conditionings, and not just the manufacturing industry but also service industry. That how architects or how MEP engineers needs to or what is the kind of business they are going to get the moment you start looking at a policy implementation. So I think a certain kind of policy intervention and how this building stock is going to help us looking at the future along with our developmental goals would be interesting to look at. If that answers your question.
So that does, and I think so. I specifically kind of find the energy flow space area very interesting as a unit. I'm not sure. Do we have something like that in India as of now, or what is the common goal around it?
Yeah, so for operational energy, we do have a matrix, which is, we call it a energy performance index of a building, which means that how much amount of electricity or energy I'm using per floor space or per unit floor space over the year. So if I translate that into a unit, it's called a kilowatt hour a meter square year. Over the year is important to include in this, because sometimes in certain seasons we use far more than what we use in other seasons like winter or summer. Hence, this energy performance index is having a time step in it. Generally, if you look at any kind of energy performance, let's say for cars or for washing machines, we don't have a time step built in that. It's like how many kilometers per liter. We don't include how many, whether it's a 1 month or 2 month. But because building does use energy depending upon outdoor conditions, kilowatt hour per meter square a year is the unit of energy performance.
Okay, and for Indian context, does it vary according to the geography, or have we standardized it? And what it is?
No, we cannot standardize because because of the seasons, because of the climate pattern, because of the climate zones. Not just about climate zones, but also usage pattern. National Building Code defines 16 typologies of the building. And these 16 typologies will have different kind of energy performance index. Even if you talk about residences, probably I have 3 people in my house, and you will have 2 people in your house, and somebody else may have all 3 generations living in the same house. A house may have a same floor space, but because there are higher occupancy or lower occupancy, energy performance index will change. So we really can't standardize it, but what we can do is at least we can create a baseline that in general, if you have looking at the national level trends, that what is the family size, and national level trend, what is the 100 square meter, 200 square meter, 500 square, 300 square meter buildings, and what is the energy intensity in that. So we definitely needs to have a baseline and benchmarks, but to standardize and to implement it for all kind of occupants or owners might be too much to look at.
Okay. And here, when we're comparing this, even at the Indian scale, how does it vary specifically with Western world? Because I think India still consumes somewhere close to 30% in at least the residential part of it, or in the building electricity, 30% electricity in the residential part. How does that compare overall across the world?
So again, this 30-40%, I am little unsure where does it come from, but 2 significant change we have from the rest of the world, and especially the Western countries. One is in many Western countries, they have more than one fuel supplied to a building for operational use. It could be gas, it could be hot water also directly to some places, and it could be electricity. So now when it comes to in India, it's predominantly electricity and not a gas or hot water. So what is a major difference is that in Western countries, they use a metric called energy use intensity, EUI, which actually normalizes the gas versus electricity and so on and so forth. Versus what we use in India is energy performance index. So EUI is a non-Indian unit, and EPI is a sort of Indian unit. At the same time, electricity generation and fuel mix within that is very different. Some countries heavily dependent upon nuclear or much lesser coal, much higher renewable source, versus in India we have a different kind of energy mix. So that's where also things are very different. But looking at the Indian context, and especially since you talked about residences, Indian government did take a very, I would say, progressive step by moving little away from energy efficiency when they were looking at building codes for residential. So if you look at India's building codes or policy regarding buildings, we have 2 separate and very different stand. When you're looking at commercial buildings, you are looking at high performance. How do we really reduce the intensity of energy? But when it comes to residential buildings, it is how do we really increase the thermal comfort without use of electricity?
Yeah.
So that's quite a bit of paradigm shift, I would say. And how to decrease discomfort is you have altogether different kind of strategies, and how to increase efficiency of a machine is another way of looking at it. So I'm glad, in fact, that thermal comfort is very much being looked at from affordable housing point of view and even residential point of view. But if you look at the energy used in buildings, or rather electricity, I would say if I have 100 rupees of income, probably Indians are spending about 8 to 10 rupees in electricity bill. So economics wise is about 10%, but I think because we have a lot of buildings or a lot of residential buildings, the energy used in buildings for residential might be higher than that, which could be 30%, but I'm a little unsure about it.
Okay. No, this is pretty interesting that if you have such a high ratio of money going towards electricity or energy per se. And so one thing that again comes back always is putting up more renewable energy across built environment. But now I'm not sure, and I think this is one of the doubts I've had for quite some long time, that putting renewable energy on tall buildings is not means it's useful, but not as much as when there is more flat structure in place or more smaller buildings in place, because then only you are able to optimally utilize the energy being generated for the whole house or flat or major amount of your electricity consumption. But generally in larger flats and all, it might only cater to your certain common utilities. Uh, but at the same time, when we come to the urban planning side of it, it is said that more compact cities are much better because then your transport reduces and everything else reduces. So how can that be balanced across in this? Because this is something just a doubt that I have had.
So, Puneet, I think we need to distinguish between, or rather, when we talk about renewable energy, we should also address or mention not just a solar photovoltaic or rooftop solar photovoltaic, but hot water or hot water, or probably biomass. And I won't say wind would be the appropriate way of looking at renewable within the city, but biomass and solar rooftops or hot water systems might be we should be sort of talking about that. However, when you say that high-rise structure, compact city does not provide more opportunity for installation of renewable energy sources, what you meant is primarily solar photovoltaic.
Yeah. Or even if I have to say, for hot water, biomass you can still get it as an argument, but for hot water as well, it would be then a bit less.
Sure. So I think that's where people who are sort of work with the scientific basis, we have I would say, reasonable amount of concern towards the sort of use of rooftop solar photovoltaic in the middle of the city. Thermodynamics doesn't help us, or rather, thermodynamics does not is not favoring having a solar photovoltaic in the middle of the city. And hence, probably we might be getting into, or rather, we are getting into another cycle of problems when we start putting a solar photovoltaic on rooftops in the middle of the city. Solar photovoltaic as a technology is excellent to generate electricity. There is absolutely no doubt about it. But distributed generation through solar rooftops, probably we really require a very, very close look. And I know whatever I'm saying will raise the eyebrows on many fronts. But let me tell you, I mean, thermodynamics doesn't help us. Thermodynamics is not in favor of us when it comes to
and why is that? If you can Just because so I'm from that background and this is a new insight for me, so I'm just curious.
So, Puneet, the way we generate electricity through this photovoltaic and efficiency which we are getting on a photovoltaic, efficiency could be probably 60-70%, or sometimes it can more. But I'm in an average looking at last 7-10 years of installation across the city. I would say 60 is also a very high number. But the amount of heat you generate, even if you are, I mean, let me put it a little simply. People have a notion that if I put a solar rooftop on my flat roof, my roof is getting shaded, so it is not getting heated up, and probably I may have a lower surface temperature on my top floor, or my air temperature might be lower on top floor. But if you look at the efficiency of solar photovoltaic, amount of solar radiation which falls on it, and amount of electricity that does it generate, where does other energy go? And that generally remains in the vicinity of solar photovoltaic panels, and definitely it is contributing towards urban heat island. Now, when you are having now extent of this needs to be looked at very closely in Indian cities, especially where you have a very large distributed solar photovoltaic distributed energy generation in the cities. But what is the benefit you're getting? Let's say if I generate 1 kilowatt of energy additional through solar photovoltaic, but my urban heat island because of that goes by 0.05 degrees centigrade air temperature. Probably I might need to use air conditioner more, and then do I really need to generate electricity on my rooftop? So it's a quite complex problem, but it definitely is leading us towards a problem which we should be avoiding. And to do that, we definitely require a science-based approach, which probably my team is working right now, but some more work is required. But inclination is that probably we are doing something which we should not be doing.
Okay, so I will not ponder on this, and I would like to read whatever research comes out. But one last question on this line is, so as you said that yes, only 15% is being utilized for energy, but whatever the case was, the energy, that sunlight was anyways coming on that rooftop, and somewhere now of that 15% is being utilized as electricity, right? Won't that be that case?
So your base light is something which is really, really bad. Let's say if I have a tar roof, I have a leaky roof, and I have placed a tar on top of it, and amount of heat which will get in my top floor versus if I have a solar photovoltaic, probably definitely you're going to have much lesser heat coming inside the building if you have solar photovoltaic. But if you have a high reflectance paint with a high solar reflectance and high emissivity, it is not going to heat up your roof at all.
Okay.
And against that, if you look at the solar photovoltaic installation, it does not favor solar photovoltaic. So, and a cool roof, so high emissivity, high SRI cool roof, is sort of business as usual in many cities now.
No, that's pretty interesting. I will surely be reading up the research whenever it comes out on this. This also does break down and get into a lot of concepts that I have had with the on-ground experience, and that is where I'm kind of more curious about this in the rooftop solar sector specifically. So now, but the other side of which environment comes is towards embodied carbon emissions. And when we are trying to, what are the different ways in which this can be lowered down? Because urbanization is happening across India, and we are going to just have much more embodied in it, but how can that be lowered down so that overall energy consumption can be reduced?
So I think embodied energy part or embodied carbon part also needs to be looked at from both sides, supply side and demand side. Manufacturing processes of materials which we are going to use or we are using in urban sector, they need to improve. Now there the diversity is extremely high. I mean, India has one of the best cement plants in terms of its efficiency, and worst of the worst plant also. So one way we need to look at it is how the supply side of building materials decarbonize themselves. At the same time, demand side, where architects and builders and developers are working, what is optimum use of cement, steel, aluminum, glass, and do we have until we make a transition towards fully decarbonization material or decarbonized material, what are the alternatives we have, whether it is agro-based products or products which are structurally extremely efficient and we really don't need to use so much of steel and cement and so forth, or can we really avoid or lessen the dependence on aluminum and glass? And that's where the supply side design interventions are going to matter. We are not just about India, but across the world, people are now looking at embodied carbon more closely, and everybody is struggling to get data. Everybody is struggling to make a matrix or matrices, I would say. So, and I think quite a few people in India are working towards that. But we are yet to find any framework which can be implemented across the country, both ways, policy-wise as well as the practice side.
Okay, so in that context now then, a lot of new frameworks are also coming. I think one of the last things that does come into then the built environment is on the line of energy efficiency. And what kind of things can be developed to make sure that buildings are energy efficient in itself, so that water utilization, electricity, energy, everything is reduced per se? What can be done to make sure of that for especially existing stock as well, because I'm sure that we are not just going to lose that out.
So existing stock, then let me give you an answer in two parts. One on existing stock and what we can do for the future buildings. Existing stock, we don't have much, I would say, options but to go for building material based retrofits. That means you have an existing wall, put an insulation, you have an existing window, change it to better glass, better performance. If your architecture allows you to have shading devices, external shading devices, just practice that. And also not just about building envelope, but also change the electricity or rather lighting on an HVAC systems. And fortunately, we have a very good business models for doing retrofits. The energy service companies, the ESCOs, who are willing to invest upfront in changing some of the HVAC or even lighting, and that ultimately will help reduce the energy consumption, will make a win-win case for consumers as well as for the companies. So I do see, although a lot of work has happened in ESCO market, but I think it's still for large building and large facilities. Individual owners or individual, even I would say, office buildings, if they really need to adopt ESCO, I think we are a little away from that. Not that we don't have a technology available, not that we don't have a contracting model available, I think, but there's a bit of credibility gap between two sectors, and that's why things are not picking up. For the future buildings, for the new buildings, definitely we need to look at not just operational energy or energy efficiency. And as I said, that two more things. Even after designing and constructing a building, whether without use of air conditioner, can we increase the thermal comfort hours? I know that the way the outdoor climates are, I am not of the opinion that we should not use air conditioner. We must use air conditioner because that links with the health and productivity and many other things. But how do we use air conditioner? How much do we use is all depends upon our building design and construction of that. You might be aware about the global cooling price work which we did, where we have already identified 80% better building systems, or rather HVAC systems. That means that technology is available, knowledge is available. Probably it's time where we nudge the policy, and through policy, market is definitely ready to provide services. But moment we look at everybody at the same level playing field, which only policy can do, I'm sure that we will be able to move very quickly.
Okay, and so I'm glad you brought up the policy wheel as well, because I think while we have all these different kinds of solutions in place now, what are the things that ULBs can do, at least the city point of view, to make sure that from policy front, all these things can actually go towards net zero and net zero built environment or something?
I think personally, I feel that we should work out a model where we take ULB out of the picture, or rather we lessen the burden of ULB. I think anything and everything we want to do in a city, we just look at the ULB as a point of contact, and we hope that you will be able to solve it. But just look at, I mean, ULBs are stretched, not just about their capacity, not just about their finances, but also amount of expectation all of us will have from the ULB. I think it's little too much. I mean, these guys are managing water supply, they're managing sewage system, they're managing transport, they're managing their schools, healthcare, and on top of that, something which they have traditionally they have not managed, and they have nothing to do with it, which is electricity. I think, to me, I think a little bit too much to expect from them. I mean, who is using electricity? I mean, Rajan Rawal in my home, in my university, I'm using electricity. Yeah. Building bylaws do have limits to govern. I mean, building bylaws traditionally, and I think even in future, I don't think the building bylaws will get into a domain of operation of a building. Building bylaws limit stops when you construct a building legally, right? So even if I am making my building as per building bylaws, and let's say energy conservation building code gets implemented by ULB, I think things stops there, and then things should stop there for ULB. If we say that, if you ask ULB that, no, you come to Rajan Rawal's house or his office and every year you check what is his electricity bill, I think it's something too much to ask for. So at the institutional level, at the ministry level, at the national level, I think we need to really debate and discuss that how do we not just build a capacity in the ULBs and ask them to enforce energy conservation building code or national building code or Econeva Samhita and so on and so forth. But I think some other responsibility needs to be given for at least operational of the building to somebody else. And just leave these guys do what they're doing and let them do that best instead of. I mean, I always say that how much can we teach kids, right? I mean, being an architecture student, we used to do surveying labeling, we used to do history of architecture, we used to do structure, we used to do design studios, sketching, and then you have a whole lot of other electives. And then on top of that, people say, hey, they must know how to design energy efficient building. They must know building and information management systems. I think it's too much to ask within the domain of. So similar way, I mean, we need to understand the limits of ULB and limits of building bylaws, and then think about something more structurally at the institutionally and structurally at the national level. And I'm saying this. I'm saying this based on, building codes have not been implemented in the most progressive states of US and China as well.
Yeah.
What does it show us? It shows that there is a limit to the system.
Yeah.
We must recognize that, and we must find a way to put this responsibility to some other system.
Yeah, it's a very interesting take, which I do kind of see as well, because so I have traditionally worked in the rooftop solar industry before I joined the urban space, and I've seen that these are the two biggest domains which don't talk, but have the most to do with whatever we are trying to do, at least on the mitigation part of it. And it just does not sync up, which is and you don't even know how to sync it up, because the asymmetry of knowledge is anyways going to be higher. So it does make sense. But so sorry, go ahead.
No, I was just saying that the water supply is a responsibility of the ULB, right? Is electricity supply a responsibility of the ULB? No. Then why are we putting them into the spot to regulate it?
Yeah, it's a very means again, the amount of departments that increase in each city, it's going to get more complex eventually as well, because information asymmetry is going to increase. But on the policy front, if we have to see what are things should be required to make sure that something like NetZero can be built up on the built environment level. Let's assume that someone will take it up, but from the policy front.
So my general attitude towards this is that yes, we need to have building codes, and these building codes must percolate down to states and ULB. Make sure that buildings which comes up, and not only building but municipal services which is actually servicing this building, also becomes energy efficient at the design stage, and then onwards. Probably somebody else needs to regulate, or somebody else needs to monitor the energy usage in the buildings. There, market can play a huge role. It's kind of services which they can offer, kind of products they can offer, not just to design a building, but also to operate a building towards net zero. I think we need not manufacturing sector as well as service sector to get excited about this market segment, buildings and operational of buildings. I mean, we know that a lot of people are into operation of hotels and hospitals, and also travel agency do operate a large fleet of cars and buses. The moment we have similar kind of service sector which managing the buildings, facility managers also needs to start looking at the buildings. Probably we will be able to reach to, because net zero is not just a design stage; it's a design and operation both. I always tell students that, I mean, if you buy best of the best car, and if you don't know how to drive it efficiently, it's not going to give you a mileage.
Yeah.
So it's not just about employing and training architects to design buildings and urban planners to design a better cities, but also management and operation of the cities. So both ways, policies and market, both needs to get excited about this net zero targets.
No, I absolutely agree with it. I think it's from the mitigation point of view, it's a pretty solid thing that is required to make sure that with the rapid urbanization that we are having, it does not cater to increase in that much electricity usage or energy usage per se. And I think to end this, the last question we generally ask everyone is on the lines of what are the different skill sets required now to make sure that things are in place to make sure make net zero built environment for the future.
I mean, as I mentioned, that on one side you have three skill sets required: how to design, how to construct, and how to operate. And that skill set definitely can come from academic institutes and researching organizations. Civil society organization can help them to percolate down to a large mass, doing just about capacity building or professional training and so on and so forth. But at the same time, we also require a skill set to manage our cities and manage our buildings towards a net zero. Although I did talk about solar rooftops, but we also, the way our houses are getting managed by washing machine, annual maintenance contract, or air conditioning annual maintenance contract. I mean, we should have that kind of services available at affordable prices, and also maintaining our buildings and large city facilities for the management. So I think it is not just about technical skill set of construction and design, but also management skill set, both at the private sector and public sector.
Okay, thank you so much. I think that was pretty concise as well on the lines of things specifically required, which is very important. Any specific things that I have missed out on in this topic and you would like to cover?
No, I think you covered quite a bit. I don't have anything else to add.
Okay. Thank you so much. Thank you for giving us your time, and we're glad that you could come on board and we can have a conversation on this, because this is surely very insightful, and I'm actually looking forward to the reading of the research on renewable energy, because that is something that does interest me a lot.
Yeah, it'll come out, but we are very conscious that whenever we come out with that study, it will have a bit of cascading effect, and hence we are very conscious before we come out with that. Hopefully, we'll be able to do that.
Thank you so much.
Thank you. Thanks, Punit, for calling me.
Thank you for tuning into the podcast. Do subscribe to the podcast on your favorite platform and follow us on all social media channels. For more details about the Climate Center for Cities and registration on Climate Practitioners India Network, click on the link in the show notes. The episode is conceptualized and produced by Punit Gandhi. A big thank you to the whole team at C-Cube and NIUA for supporting the development of the podcast. Stay tuned for the next episode.